Hello, welcome to the third lecture for the Mathematics Class 11, Chapter 7, Linear Inequalities. So, till now, we have tried to define what are linear inequalities. We saw how we can express them in terms of, mathematical expressions. We saw how we can represent them. We also saw how we can convert statements which give you conditions or limits or a certain, range of amount. If they are given in a statement form, we saw how we can convert it into linear inequality. We also saw some rules that are related to when we are applying few algebraic operands on linear inequalities. So just to revise, okay. So suppose your linear inequality is say 2x minus 1 is less than or equal to 5. Okay, so if this is your inequality that is given to you, so your first step would be to simplify it. Okay, so first, to simplify, you can first get the bracket out. Okay, and later on, we have also seen that when it comes to linear inequalities, we can add or subtract the same number from both the sides of the inequality to simplify the linear inequality further. So if you take this as 2x minus 2 plus 2 and 5 plus 2. Okay, so we are adding plus 2 on both sides. So what we get is 2x is less than or equal to 7. Okay, so this is now simplified. Okay, so and the next point that we have seen is that you can multiply or divide the same number. Okay, so same non-zero number on both the sides of linear equalities. If it is positive, the sign of inequality does not change, it remains the same. But if you divide or multiply with a negative non-zero number, okay, so a negative number, then the sign will be reversed. So with this aspect, if we divide both sides by 2, you get x is equals to less than or equal to 7 by 2. But if you divide it by negative 2, what you get is minus x is less than or equal to minus 7 by 2. Okay, so you can see that the sign is reversed if you divide or multiply with a negative number. Now, if you want to, kind of remove the negative sign on both the sides, you can again multiply both the sides with negative 1. So what that will give you is x. Again, since we are multiplying with negative 1, okay, so it can then turn into, again, you see the sign has reversed again. And this is what we had got by simply dividing both sides by 2. Okay, dividing both sides by 2. Okay, over here we got this by dividing both sides by minus 2, and then this is multiplying both sides by minus 1. Okay, so these are some of the rules that we had learned in the previous class and which we follow when we are trying to solve the given linear inequalities. Okay, so now we will move on to see how the solutions of x. Okay, so we always have, we get multiple solutions for a variable x, in a linear inequality. Okay, so we can get a number of solutions or number of values of x for which the linear inequality statement becomes true. Now, you can actually represent all of these values on the number line. Okay, so number line is nothing but a line which extends on both the sides. Okay, and it is kind of a graphical representation of the numbers, and we use that number line for graphical representation of the solutions of x also, x of variables, x or other variables. So the number line can be, kind of represented as the midpoint of the, or any point on the number line. If you denote it as 0, okay, so the right hand side would all be positive numbers, say real or real numbers or integers, whatever is that they are looking for, or whatever are the conditions. And on the left hand side, you will get, or you will write, or the negative real numbers or integers. Okay, so actually negative numbers. Okay, so all negative integers. Okay, so similar way you can have. So you can have, say, 1, 2, 3, 4, 5, 6, and then so on. And similarly, you have -1, -2, -3, -4, -5. Okay, so suppose you have got x is more than or equal to 2. Okay, so this is the kind of, the solution that we get. So all the values, or all the numbers on the number line which start from 2 and are greater than 2 will be represented. Okay, so you can just draw your red line starting from 2 all the way to up to whatever is being uh, marked. Now over here, all the values that are more than 2, equal to and more than 2 will be marked. So the number line extends, so you do not need to show the entire kind of range of the numbers, but you can show it up to the number line that you have represented. Now the next one, suppose the next kind of solution that we have is, say, x is less than 3. So now over here you can see that all the x has to be less than 3. Okay, so you can start a little left of 3, and then you can mark. Okay, you can mark the number line on the left hand side, because that, when you say x is less than 3, it will also cover all the negative numbers also. Okay, so this is how we graphically represent the solutions of a linear inequality. So let's take a few examples. Suppose your question is 2 x minus 1 by 5 is more than or greater to 5, 1 minus x by 2. Okay, find the solutions and graphically represent them. Okay, so now we first need to get the linear inequality in the simplified form. Okay, so we want to take out the denominators on both sides. So what we can do is we can multiply both the sides with 5 and 2. Okay, so multiply both sides with 5 and 2. So you have 5 into 2 into 2x minus 1 by 5. So by 5, and that is greater than 5 1 minus x by 2 multiplied by 5 and 2. Okay, so over here your 5 goes away and 2 goes away. So what you get is 2 into 2, 4. So if we quickly expand the brackets also, we get 4x minus 4, and you have 5 and 5, so 25. So multiplying 25 with the terms in the bracket itself. So 25 minus 25x. Okay, so this is what we get. Now, to further simplify, we can get the all the variables on one side. If we try to do that, you can again add 25x on both sides. Okay, so you have, so that we can remove the x variable from the right hand side of the inequality. So you have 25. Okay, because if we add plus 25x over here, so they will cancel each other out. So now we get 29x minus 4, 25. Okay, so if we add 4 on both sides, we get 29x. And quickly, if we add plus 4 on both sides, we get 29x. Plus 4 and minus 4 gets cancelled, and that would be 25 plus 4, so that is 29, and therefore x is greater than or equal to 1. Okay, so we have got the solution that x is greater than or equal to 1. Okay, so when we represent it now on the number line, okay, so suppose this is your number line. You have just take 0, you have 1, 2, 3, 4, 5, similarly minus 1, minus 2, minus 3, minus 4, minus 5. Okay, so our solution is that x is equals to x is greater than or equal to 1. So we will mark all the numbers on the number lines, okay, from 1. Okay, so this is your graphical solution for this linear inequality. Okay, so all the numbers, all the way, actually the solution set that you will eventually get is x is equal to 1, comma, all the way up to infinity. Okay, so you can get, this is your solution set, and that can be represented in the graphical form as per that we have shown. Okay, now let's take another example. So question would be, suppose you're given given an inequality in the form of, okay, so find solutions for x and show them graphically. Okay, so let's solve this. So you have 37 minus 3x minus 5, 9x minus 8x plus 24. Okay, so let's start simplifying it. So you can have this as 32 minus 3x, and this would be x plus 24. So if you want to take out the x's, or we want to get all the x's on one side. So if you subtract minus x on both sides, you get 32 minus 3x minus x. So x minus x will get cancelled. So you're left with 24 here. So this is 32 minus 4x. And this is 24. Okay. So now if you add, or you can subtract 32, okay, from both sides. So what you get is minus 4x is greater than or equal to 24 minus 32. Okay, so that will give you minus 4x greater than or equal to minus 8. Okay, now if you subtract both the sides with minus 4 itself, okay, so that is one thing that you can, when you get simplified linear inequality in this terms, that only one term with the x variable and only one constant is present on the other side, you can divide both the sides by the coefficient of the variable. So over here the coefficient of the variable is minus 4. So what you can do is divide both sides by minus 4. Now, since we are dividing both sides by minus 4, the inequality sign will be reversed. So therefore, what we will get is x is less than or equal to 2. Okay. Since dividing both sides with minus 4. Okay, so this is what we get. X is less than or equal to 2. So therefore, your solutions will be actually, the upper limit is going to be 2. Okay, and all the way up to your negative infinity. It will take in all the negative numbers also, because x is less than 2. So now again, when we have to represent it on the number line, so we have 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so now to represent it, represent the solution that we got graphically, so it has to be less than or equal to 2. So all the way from 2, okay, so you mark the number line, okay, all the way up to you're covering all the negative numbers also. So this is how you can represent the solution on the number line for when your x is less than or equal to 2. Okay, so let's take another example. Okay, so the question, suppose, is x by 3 less than or equal to x minus 1 by 2 minus 5x minus 2 by 3. Okay, so again, you find the solutions and represent or represent graphically. Okay, so we have the question. So now, before we start dealing with both sides of the linear inequality, we will first try to simplify the right hand side only. So what you have is x by 3 is less than or equal to, so this becomes 6. So you have 9x minus 3 and then minus 10x plus 4. So this becomes minus x plus 1. Let me write it in the other form. Okay, so you have 1 minus x by 6. Okay, so this is what we get. Now, you can do one thing is that, to get the denominators of, you can multiply both the sides of the equation with 6. Okay, so with 6, if you multiply both the sides with 6, you get 2x less than or equal to 1 minus x. Okay, so your 6 goes away, and over here, if you have 6, so 3 divided 6 divided by 3 will give you 2. Okay, so you have 2x less than or equal to 1 minus x. Now again, we will try to bring all the variables on one side. So if you add x on both sides of the inequality right now, what you get is x, 2x plus x. And since we are adding x on both sides, we get 1. Okay, so your minus x goes away. So then you are left with 3x is less than or equal is greater than or equal to 1. And hence x is greater than or equal to 1 by 3. Okay, so now you can see that 1 by 3 in itself is, a fraction. So it is an integer, it is a positive integer, but on number line, if you want to understand where you want to start representing it on the number line, you can quickly see that x would be greater than or equal to 0.33. Okay, so you start it between 0 and 1. Okay, so if you draw the number line, you write 1, 1, 2, 3, 4, 5, 6, 7, minus 1, minus 2, minus 3, minus 4, minus 5, minus 6. Okay, so now we are saying that x is going to be greater than 1 by 3 or 0.33. So say your 0.33 lies somewhere here. Okay, so you mark on your number line from that point all the way towards the positive side, because x has to be greater than that. Okay, so it will cover all the uh, numbers, integers, okay, on the right hand side of the number line. So your solution actually is x is equals to, the solution set that we have is 1 by 3 comma infinity. Okay, so that means all the numbers up to your infinity is going to be included and represented over here graphically. Okay, now let's see if you are, so if you're given, okay, so you're given a kind of a graphical representation. Okay, and then you have to find the solution. So for example, you are given, this is your x-axis, y-axis, this is minus 3, and this is 3, this is a 0. Okay, and suppose this region is shaded. Okay, so the question is actually derive the inequality represented by the graph. Okay, so suppose this is what you are being asked to solve for. Okay, so the shaded region that is given to you, you have to find the inequality that is representing this shaded region. Okay, so as you can see that the bounds that are mentioned here is between -3 and 3. Okay, so the shaded region lies between -3 and 3. Okay, so therefore you have x either being equal to -3 or x is equal to 3. Okay, so it lies between 3, but since actually this is dotted lines, okay, so when they are dotted lines, we are not going to consider the values. Okay, so therefore x is actually not going to be equal to 3, or it's going to be or it's also not going to be equal to 3. Okay, so therefore your x actually lies between -3 and 3. Okay, so -3 is going to be less than all the values of x, and 3 is going to be greater than all the values of x. Okay, so since the lines are dotted when passing through -3 and 3. Okay, so we are not going to use less than or equal to sign. We are just going to use the less than sign. Okay, so therefore we can say that your x is going to be a mod of x is going to be 3. Okay, so if you have any plus minus x whatever, this will happen because mod of x, okay, whether your x is +3 or -3, okay, so that is going to be less than any of the numbers that you're going to get. Okay, so if you even have if your x is -2, it is going to be less than 3. If your x is 2, that is again less than 3. Okay, so this is how we get. Therefore, minus x a. Okay, so this is what we find. Now, suppose, okay, so suppose the condition given to you is that x is less than -3 and x is less than 3, and also your x will be equal to -3 and x is also equal to 3. So then your linear inequality is going to, it can be represented as -3 less than or equal to x and x less than or equal to 3. So therefore, then this now becomes that mod of x is going to be less than or equal to 3. Okay, so it depends. Now, if these lines were, not dotted, so if you had shaded lines, x and y, this is your -3 and 3. These lines are also, included, and this entire region would be shaded. So then you can say that this graphical representation or this graphical solution is actually representing the linear inequality that mod of x is less than or equal to 3. Okay, now let's try to find or solve linear inequalities when they are derived from statements. So we had seen, kind of how we can derive the linear inequality for a statement that is given. So Anil has obtained 70 and 75 marks in the first two tests. He needs X marks in the third test. Okay, so we have to find the solution, find solutions for X. Okay, or we need to find that what is the minimum marks that is needed by Anil in the third test so that the average of it is at least 60 marks. So since we have already, it's not let, we are already given X is the minimum marks to be obtained by Anil in third test. Okay, so as for the linear inequality, 70 plus 75 plus X divided by 3 has to be more than or equal to 60. Okay, so this is our linear inequality. Okay, expressed in the mathematical form. Now, if you multiply both sides by 3, what you get is 70 plus 75 plus X. Now, 3 and 3 gets cancelled. Okay, so you get 60 into 3, that is 180. Okay. Multiplying by 3 on both sides. Okay, so this is what we get. Now, if you solve this, you will get 145 plus X is equal to 180. So if you subtract both sides by 145, okay, so that we can get only the variable on the left hand side, you will get 180 minus 145. 180 minus 145. So that is going to give you X is more than or equal to 35. Okay, so therefore, Anil requires a minimum of 35 marks in his third test. Okay, so you can see how linear inequality can help you understand the kind of minimum or maximum value that is required in certain scenarios. Let's take another example. Okay, so in the question we are being asked to find the total number of pairs of consecutive odd natural numbers, both of which are larger than 10, such that the sum is less than 40. Okay, so first, how we go about solving this is that we will try to get it in the term of a linear inequality. Okay, so you have, so suppose we say let X be the smaller number of the pair. Okay, so you have two numbers. Okay, so the smaller number of that pair is going to be X. Now we are saying that these are all pairs of consecutive odd natural numbers. Okay, so therefore the second number of the pair is X plus 2. Okay, now we are saying that both of these are going to be larger than 10. Okay, so your X is larger than 10 as well as your X plus 2 is going to be larger than 10. Okay, so this condition is also, it's given. And the other given is that the sum their sum is going to be less than 40. So that means that your x plus 2. Okay, so the sum of the pair of the numbers is less than 40. Okay, so this is our final, linear inequality that needs to be solved. Okay, so what you get here is, yes, so you have, you can directly write, you have 2x plus 2, okay, is less than 40. Now you can subtract 2 on both sides. Okay, so if you subtract 2 on both sides, you get 2x less than 40 minus 2. Okay, in that you will get 2x divided, 2x is less than 38. Okay, so now dividing both sides by the coefficient of the variable x, you get x is less than 38 by 2, and that is going to give you x is less than 19. Okay, so now we know that your x is larger than 10 but less than 19. Okay, so the smaller number of the pair. So all your x's are going to range between 10 and 19. Okay, so this is the solution, kind of what we get. So if this is a solution, then all the odd numbers that you have between 10 and 19 are going to be 11, 13, 15, and 17. Okay, so these are all the smaller numbers of the pairs. Now we are saying that each pair is consisting of consecutive odd natural number. So therefore, the pairs are, so you will have one pair as 11 and 13. Okay. Then the other pair is going to be 13 and 15, considering 13 as the smaller number of the pair. Then similarly, the other pair is going to be 15 and 17. And the last pair, okay, so the smaller number is 17. So your x is going to be 17 and the other number of the pair is 19. Okay, so therefore you have 4 number of pairs. Okay, so we had to find the total number of pairs. So we have 4 number of pairs. Okay. So this is how you can find similar, if you are asked questions in the similar manner, this is how you can find it. Now let's take another example. So you have a triangle. Okay. So the longest side of the triangle is 4 times the shortest side, and the third side is 3 centimeters shorter than the longest side. And we are giving the perimeter of the triangle that is at least 87 centimeter. So what we have to find is the minimum length of the shortest side. So let the minimum length of shortest side be x. Okay, now since that is x, we can find the relation with the other two sides. Okay, so we are saying that the longest side is 4 times the shortest side. So it is 4x. And the third side, the condition is given that the third side is 3 centimeters shorter than the longest side. So that would be the longest side and minus 3. Okay, so this is x centimeter, 4x centimeter, and this is 4x minus 3 centimeter. So now the perimeter of the triangle is given. So perimeter is the addition of all the lengths of the sides of the triangle. So therefore, the perimeter, okay, is equals to 87. So it is at least, okay, so at least that means it has to be, so your perimeter, it has to be greater than 87. Okay, so perimeter is the addition of 4x plus 4x minus 3. Okay, so let's just rearrange the equation to get the all the variables on the left hand side. So you have x plus 4x plus 4x minus 3 has to be greater, has to be greater than 87 centimeters. Okay, so now let's simplify LHS. So you get 9x minus 3 greater than or equal to 87. Now, if you solve this, you can add 3 on both sides. So you can, get rid of the minus 3 on the LHS. So you have 9x greater than or equal to 87 plus 3. That is 9x is greater than or equal to 90. Now you divide both the sides of the inequality with the by the number of the by the number that is the coefficient of the variable that is given. So this is divided by 9. So you have x greater than or equal to 10. Okay. So therefore the minimum length of the shortest side of the triangle is 10 centimeter. Okay, so if the minimum length of the shortest side of the triangle is 10 centimeter, you can easily find the minimum length of the other sides of the triangle. Okay, even though it is not asked, we can find. Okay, so we had seen that the longest side is 4x. Okay, so therefore minimum length of longest side is 40 centimeter. Okay, so this is the minimum length because we are saying since your x has to be greater than or equal to 10. Okay, so the minimum, the solution that you have, the solution set would be starting from 10, 11, 12, all the way up to, if you're considering real numbers, it can go all the way up to infinity also. Okay, so the third side, the condition that we had was it is 3 centimeter shorter than your longest side. So 4x minus 3. So therefore, minimum length of third side is, so you have 40 minus 3, that is going to be 37 centimeters. Okay, so this is what we get. So, these are all the minimum lengths. Okay, so if your x becomes, if you have that x is equals to 11, all the minimum lengths of the longest sides will also change because there's a correlation between the shorter side of the triangle as well as the longest side and the third side of the triangle. Okay, so this is how you can find. And also, obviously, if you add them up, the minimum, so therefore the minimum perimeter using all the minimum lengths of the lengths of the sides of the triangle, it's 10 plus 40 plus 37. That is eventually going to give you 87 centimeter. Okay, so it's very easy to solve linear inequalities when from statements itself. Okay, so we'll do one more example. Okay. Okay. So suppose the question is x minus 4 by 3 is greater than or equal to x plus 2 by 6 minus 1. Okay, so you have to find the solutions and represent them graphically. Okay, so you have x minus 4 by 3. So let's first simplify your right hand side so that it's easier for us. So you have x plus 2 minus 6 all divided by 6. So this gives you x minus 4 by 3. And you have x minus 4 by 6. Okay. Now if you multiply both sides by 6, okay, so to get rid of your denominators, what you get is x minus 4, sorry, this would be 2x minus 4, because this we get multiplying 6 on both sides. Okay, so 2x minus 4 greater than or equal to x minus 4. Okay, 6 goes away when we multiply both sides by 6. So this you get as 2x minus 8, x minus 4. Okay, so if you want to take out x, get rid of the x on the right hand side, you subtract both the sides of the inequality with x. So you get 2x minus 8 minus x equal to minus 4. So this you get as 3x. Okay, sorry, this would be only x. Yeah. So this would be x minus 8 minus 4. If you add both the sides by 8, to get rid of negative 8 on the left hand side, so you get x minus 4 plus 8. Okay, so what you get is x is greater than or equal to 4. Okay, so this is your solution. I'll write it on the side so I can draw the number line. X. So this will give you x is greater than or equal to 4. Okay, so then you get a number line. You have 0, 1, 2, 3, 4, 5, 6, minus 1, minus 2, 3, minus 4, minus 4, minus 6. Okay, so now we see that our x is supposed to be greater than or equal to 4. Okay, so no number below 4 is going to be considered as a part of the solution. So hence we can write that 4, starting from 4, okay, all the numbers towards the right hand side of the number line is going to be our solution. Okay, all the numbers there, because since your x, the solution set is going to be 4 onwards up to the infinity. Okay, So you can see that it is easy for us to solve linear inequalities, and the help comes, when we have to find the limit of certain of certain things. So suppose as we had to find the minimum length of the sides of the triangle, or minimum number of marks, or you can also have minimum temperature, minimum speed. Okay, so first, any statement that is given to you, you try to write down all the conditions that are mentioned. Okay, then you form your linear inequality. Okay, so when you're forming the linear inequality, you might have a number of uh, terms consisting of the same variable. Okay, so you simplify it to get only one variable, okay, one term with the variable on the left hand side of your inequality. And then you use the rules of addition and subtraction, or adding and subtracting the same number on both sides of the linear inequalities to simplify your inequalities. Or you can multiply or divide both the sides of the linear inequalities with either positive numbers, okay, or negative numbers. But when you do it with the negative numbers, you have to keep you have to note that the sign of inequality will get reversed if you divide or multiply the both sides of the linear inequality with a negative number. Okay, so these are some of the things that you have to remember when you're solving for the inequalities. And wherever, suppose if you're given a mod, okay, a mod with the variable inside, so you have to consider that the x could have both plus as well as minus, kind of solutions, and you can solve it appropriately in that manner. So this is the end of this chapter. It's a short one, but it will help you when you have to solve, further, when you have in conditions, boundary conditions in physics, or you have to keep a check on the limits or the ranges that you have to, stick to when you're solving a few examples. So thank you so much for attending these classes. Hope this has helped you.